All right, so this week should be pretty straightforward. It'll be a little short. This one's all about NAT and doing address translation. And you'll have two types of NAT. You'll have source and destination. If the clicker would click, let's click. There we go. All right, so again, you'll start seeing this flow logic up here all the time now because it'll make sense as to where we're at in the process. So again, when a packet comes in the upper left-hand corner, it always asks whether or not this traffic matches an existing session. And if it does, then go ahead and start on down through the inspection and enforcement section. If not, then we're going to go ahead and set up a new session, which means it needs to go through that entire chain at the top, determine whether or not it fits, and if it does, go ahead and get a session ID. From there, it can go ahead and pass through the rest. So what we're going to be looking at here is in this destination zone and whether or not that includes a DNAT check up here at the top, right about there. And so again, there's two different NAT types we're worried about. We're going to do source NAT, which is commonly used for private or internal users to access the public internet, aka outbound traffic. This is what you guys normally do at your home, right? So your router has a public IP address. You guys go from that public to your private network, the 192.168.1.x by default on most devices. And that allows you to have multiple inside devices get access to the internet, right? Then you have destination NAT, which is often used to provide hosts to a public external network access to the private internal network. So for example, down here at the bottom, it would allow you to come in from the internet, hit the firewall, and get back out to the extranet going out there, okay? So source NAT is going to translate an original source IP address to an alternate source IP address. So for example, if you're coming in off the user's net, you're going to have a 192.168.15.47. You're going to hit the network and want to go out to the internet. Your public IP, or the outside of your firewall, is the 198.51.100.22. That's what you're getting translated to. And then on all the way out to the internet, which is your 203.0.113.38 in the case of our lab. So before, you're going to be taking your source address of this 192, not that one, that one. This 192.168.15.47 heading out to the internet, and you're going to translate that over to this 198.51.100.22. Now, that's because we have multiple networks here. In order to go out, this pretends to be a public inside of our network. Typically, you would just have one connection here and then routing that all the way up, right? Everybody kind of understand how that works? You can do a couple different ways of source NAT. You can do a static IP in which you have a one-to-one fixed translation. That will be like changes of the source IP address as they leave the source port unchanged. It supports implicit bidirectional rule feature. This is something I would do like here on campus, where I may have a block of public IPs, and I want to take one of those public IPs and map it directly inside to one device on my local network, all right? More than likely, what you guys have been doing in the past is something like dynamic IP and port number. That's what most of you guys are used to. And what that allows you to do is use a public IP address with different source port numbers. And then you guys may have heard of it as PAT, that kind of thing, where you're doing port overload. It's allowing you to translate that on the inside. So on the inside, you may have port 80 hosting your web server, but when it actually goes all the way out, it may be translated to a different port on the outside public network, right? Dynamic IP, that's your one-to-one translations of a source IP address only, not the port number. And therefore, you can have private source address translations to the next available address in the range. Essentially, we give it a range of public IPs, and it just kind of keeps rotating through as it goes through, right? The first one's handy because we don't have to do anything to do with ports. So those of you guys that host Minecraft servers at home or something like that, right? You have to take your inside IP address, take that port number of whatever it's running on, and then translate that out to your public IP address on the same port number or maybe a different port number of what you expose to the internet. When you do a one-to-one static, you don't have to do anything to do with ports. it is as if it's the IP address on the inside. So if you want to limit ports, that kind of thing, you do it in the firewall of the device itself or in your security policies on the firewall itself. And then your dynamic IP and port, this allows multiple clients to use the same public IP addresses with different source port numbers, and the assigned address can be set to the interface address or to a translated address. In this case, this is what you guys mostly use at home, this last one down here at the bottom, where you're taking a public IP address and translating it to multiple inside addresses. So a lot of times when it goes through the firewall, it's going to be a really high source port, like 55,000 something. On the inside, it's really going to be like port 80 or port 8031 or whatever you guys are setting up on the inside. All right. On the outside, you guys would typically have it set to the interface address, which would make sense on a firewall at home. You only have one public IP. You would set it to the interface address. If you had a block of IP addresses, you could set that up as a translated address. What that allowed that to do is the firewall would respond to a public IP on one and another public IP and another public IP all on the same interface, right? So one interface does the communication out, but it also has an ARP table that says I am also .13.14. Whatever else on the public side. And that way you can translate those to inside IPs. Most of you don't have a public block of IP addresses. Most businesses don't have a block of public IP addresses. Usually a school or somebody like that is going to have this giant block, and then it kind of gets chopped up after that. Now, you can sometimes get those, you just have to pay for them. So for example, if you want a static IP address from a local ISP here, it's about $10 a month, right? Otherwise, you're going to have a DHCP address. If I want multiple of those, I would pay multiples of 10 for every static IP address I have on the outside, or more, because at that point they may charge you as a business and charge you a lot more fees on top of that. So what that looks like in a NAT policy is you go into your policies at the top, then down to NAT, and then from there we're going to have our sources. So our source users going out to the internet. This is where our source destination is set to our users net. Our destination is set to the internet. We have a source IP address of anything in the 192.168.15.0/24, destined for any, right? Because we're going out to the internet. We have no idea what we're going to end up translating it to. And at this point, we're going to be using dynamic IP and port off Ethernet 1.1, and this is our public IP address, right? And we can see in this case that we have a pretty high hit count, meaning that it's translating lots of packets as it's going through. Even though you have a NAT policy, you still have to have your security policy, which is what you guys did last week, right? So that was your users to the internet policy down here at the bottom. And you can have your users net, again, that same subnet going out to the internet on any address. In this case, we're going to allow SSL and web browsing. And then does anybody remember what service application default allows?
Yeah, it was the HTTP and HTTPS.
Correct. Yep. It is specifically stating port numbers it allows. And in this case, it's allowing port 80 and 443. Yep. All right. So when you configure that policy, you create a new one up at the top. You're going to see it. It looks very much like a security rule policy where you have the original packet. This is where it can get a little tricky and cumbersome when you're doing NAT packets. I'll be honest, I almost always configure it backwards in my head, all right? Then I realize I need to flip it the other direction. So what I found over time is you have your source packet over here, or your source zone. You set your internet or your destination zone up here, and a lot of times you'll end up setting this destination interface, which will be your outside interface, right? Just depends on how you're configuring this source NAT. In this case, they are restricting it down to just this subnet for the source address block. You don't have to set this. It could be anything coming from that zone, setting it over, but making up sure a source address block makes sense. Then when you go to your translated packet, you're going to, pick which one of these you want. Most of them are going to be, like if it's for generic traffic going out and no servers or anything like that, you're going to be using dynamic IP and port, your interface address, Ethernet 1.1, and then your IP address as it goes out there, right? And again, this will pull automatically. So when I click the drop down for 1.1, it's automatically going to fill in the IP address of whatever I have assigned to that public interface. If I have more than one address associated with that interface, they would show up in the dropdown for the IP address. All right. Notice over here, you do not fill out anything on the destination address side, right? That'll be DNAT. That's the other one that we haven't talked about yet. On a one-to-one translation, this is where you would do everything the same, only the difference is this is going to be a specific source address versus 15.0/24. You're now going to say 47. Over here on the translated packet side, you're going to say static IP and whatever public address you want set there. You can set that up for bidirectional so that you don't have to set up both sides of it. All right? It will translate in and translate out. For a dynamic IP only, you would again do the same thing. What this is going to do is say for this block of IP addresses on the inside, .2 to .50, we are going to use a dynamic IP on the outside of 102 to .150. Does that kind of make sense? It's like a static, only we are going to use a pool for this pool of inside addresses to this pool of outside addresses. And it does not map one-to-one on those going through. Does that make sense? In other words, 15.2 does not necessarily map to 102. It just pulls one from the pool in the next available one. So if the first host that lights up over here is .30, its outside address will more than likely map to the 102. Okay? If I wanted it specifically to map to one, that's where I use the static translation up above. For example, this one would be 47, specifically goes to 22 in this case. Anybody have any questions on that? Again, the NAT translation thing is confusing. Trust me, when you go to configure it, for whatever reason in my head, it always seems backwards of what it's supposed to be in cases. All right? So if you get stuck with it, I encourage you to do this lab a couple times until you really understand why you're doing what you're doing. Does that make sense? Okay. On the dynamic IP and port translation, this is where you would set up, just the whole block of IPs that would come in here at the beginning. And then instead of going to one IP on the outside, you could actually translate it to a block of IPs. In this case, 22 and 23. Does anybody know what the benefit of that would be? Of having multiple publics? RJ, anybody in industry?
Well, some people will have them to keep different types of connectivity completely separate, like, for example, PCI compliance. You might have a separate network that doesn't have any ports open, and then you can keep that customer credit card data separate from the rest of the network. That would be one reason.
Yep. So that's one way that you may want to do this to multiple IPs. A lot of times what you'll see here is I've got some user on this 192.168.15.x network. They are compromised, spyware, virus, whatever else it is. They start sending a bunch of stuff outbound, or they start attacking stuff out in the public. What's going to happen on the far side? Say it's Amazon.
It's going to get blacklisted.
Exactly. You end up getting blacklisted. What that will do is blacklist one of these IPs, whichever one it was tied to going outbound. It means that these guys won't lose internet connectivity or have a bunch of issues with that vendor as long as there's more than one IP available. Does that make sense? So a lot of times you could set this up as a pool where, okay, if my users got compromised and one of my IPs get blacklisted, I could still have some traffic outbound. The other idea is that you just set it to 22. When that gets blacklisted or something happens, you go in here and change it to 23. Everything's hunky-dory. You start working with that vendor to get your IP address unblacklisted. All right? You can go both directions. This is kind of beneficial because more than likely it's going to happen at a time where you're not around to make the changes in the firewall, and it could cause some issues. So having a couple IPs available on the public side is helpful. That's at least where I've seen it, where we've had users go get blacklisted, and then it was really nice to have a couple IPs available. But we sometimes don't want to use that whole pool over here, like what you saw on that previous slide. I tend to not give it this whole pool. I'll just give it a couple IPs. What's the problem with not having the same number of IPs here as you have here? You got it. At some point, somebody's going to run out of IP addresses, and you can't have something to map to the real world. So you kind of run a little bit of a game. If you know only, 20 of these users are ever on at one period of time, then maybe I only need 20 IPs over here, right? But if they kind of come and go and you never know what it is, then you kind of want to have the same number on the outside. Now, we always think of it as going from private to a public address. That may not necessarily be the case, right? Because in the case of this here, we are translating to this outside interface network, which then gets routed up to the internet and on out. We may have the entire control over this block, which may not necessarily be something else. So I could translate private to other privates if I wanted to, right? It doesn't have to be a public address that I translate things to. So if you end up double natting some stuff, that may be a reason for you to do that on that side. Okay. DIP NAT over subscription. This basically is the same translated IP address and port pair can be used multiple times in concurrent sessions. And so it assumes that the hosts are connecting to different destinations. You can set up these session settings over here in your device setup. Up here, if you follow this section here. Oh, I double clicked and got the red now. You can actually set your subscription rate over here. So you can do the platform default, or you can do 1 times, 2 times, 3 times, etc. That is based on the number of address pool sizes you have over here. So what that means is my internal source port is 26435. I have a firewall source port of this 25661. Destination is going out here, right? What this does, as you can see, is I'm reusing that same port on the firewall multiple times with different internal source ports and different destination IPs over here. All right. It knows because, yes, this port is already in use by this one here. However, I know that it's coming from this address. Therefore, I will map it back to this internal port. Right. It's a way to get more out of your NAT than what you would normally get if you specifically said you only get 1 port per IP address kind of thing. Obviously, it has to be used with caution, right? Because if this user that's using this port is going to 51 and this user on this port is also going to 51 and they're both getting translated to the same public source, it has no idea where to route traffic back at that point. The firewall will see it's coming from the same destination, or in this case, source, when it comes backwards. Therefore, it won't know where to map to these specific ports on the inside.
Will that possibly bottleneck if everything is using the same firewall source port?
Yeah, what you'll end up doing is dropping traffic because it won't know where to route it. Yep. A lot of times this only plays out if you don't have enough public IPs, right? So like we said before, at your house, you typically only get 1 IP. At some businesses, you're only going to get 1 IP. So you may want to do like a 1x or 2x over subscription rate if you need to, if you start having port issues going through there. Okay. All right, destination NAT is what's going to be used to translate an original destination IP address to an alternate destination IP address. So for example, somebody out here on the internet wants to come in and access this server on the outside. Their source is this 203.0.113.38. Their destination is this 198.51.122. We want to end up translating that back to an internal IP address of 192.168.16.2. But notice it's where the origin of the packet comes from, right? So before, we were sending packets from the inside out. Now we're sending packets that are coming from the real world back into the firewall. And remember, firewalls care whether it's going inbound or outbound. Those are 2 separate rule policies coming out. All right. A lot of times where you'll see destination NAT is things like this, where you have an extranet and you are hosting web servers or something like that the public is hitting. Obviously, we don't necessarily need the public finding a way back into our firewall to hit Joe's laptop because he's running a web server on it, right? We shouldn't have that exposed to the internet, but we may want our, our web servers and stuff obviously exposed out to the internet and communicating here. So essentially does the opposite of what we normally think of. To configure that destination NAT, you have your source zone still set up as internet. Your destination zone is also internet. That makes, this is where it can get a little tricky, right? Before, we went from a source zone of our user's net going out to the internet, right? Now it's going to be our source zone is internet, our destination is internet, and our destination address is whatever public IP that we assign to this outside interface, or our outside access to this server. And now when we set up our translated packet, we leave this side blank, and we're going to set up a static IP to point to a specific private IP on this side. Okay. So for static one-to-one translations, this is again going to take that. You guys would set up this side here. Notice also set up by a static NAT source bidirectional offset, so it will create it on its own if you have it set up. Over here, you could specifically say you want to go into another port. So on the outside, if you're hitting something like 80, but you have your actual server running on something like 8,000, you could do that translation all in the firewall in one whack. That makes sense? All right. The rule, the security policy rule is you would need to set a destination NAT policy that would say anything coming from the internet, destined for the internet, destined for this public IP address, allow the service of 80, right? And TCP 8080. It covers both of those. And we're going to translate that out over here. All right. So this is the NAT policy that's going to be set up. And again, you would still have to set up a security policy to match with that. On your dynamic IP address support for this is going to translate an original IP address to a destination host with a DHCP assigned IP address. And that translated address could be a fully qualified domain name, an address object, or an address group. These last two are things that we set up in the firewall. So an address object means that I went into my objects, I took this IP address, and I call it this server. It's a way for me to do something in the firewall with just the name of the server from now on and not memorize its IP address. It's specifically useful if there's DHCP assigned on the inside. Normally, you wouldn't have DHCP assigned to your servers, but you might for some reason. Does anybody know where you might use DHCP addresses as opposed to statics for most servers?
You need DDNS if you're doing that. I know that.
Yeah. Yep. You would need to do DDNS or have the firewall do that kind of thing. The main reason for something like that would be in the newer technologies that are out there, something like Kubernetes and that, where it's automatically pulling DHCP addresses. You're not statically assigning this server. A lot of times you'll have outbound stuff tied to a load balancer, which would have a somewhat static IP, but even that may be DHCP assigned at this point. So this helps you do that translation. That is where you're going to have this address object built into your firewall. Because it's handing out the DHCP, if it's handling DHCP, it knows what address to translate to, right? We just say we have an address object called PanW web server. In the system, it will go do that lookup every time it tries to translate that across. Right? So for that one, you're going to have the same kind of setup as you do over here, internet to internet, going out to your destination address, and you're going to be setting that up as a very specific destination on this side. Right? And then again, in your security policy, you need something to match that. So you will have something going from internet to the extranet on this IP address. You want to do web browsing and application default. Note that this looks a little different than here, right? This is your pre-NAT zone going to internet. Down here, you're going from a source of internet to a destination of extranet. It's the post-NAT zone going through. Destination NAT is where things get a little bit goofy, right? Does anybody have any questions on destination NAT for this point? Again, where you're going to be using destination NAT is you are hosting some service that the public is trying to get access to on your side, and that service has a private IP address. It's on your extranet or something like that. And we need to translate that back out to some public address. Bidirectional source NAT. This is going to enable internal servers to be able to send and receive traffic back through the firewall. It's only available for static NAT. So if I do a static IP translation, I can do bidirectional. It will automatically set up the opposite side of it for me. So for example, here at Fort Hays, I take one of my public IPs, I map it to a VMware server on the inside. I wouldn't do that to a VMware server. That's bad, but you could. And in that case, I want that server to be communicating in and out. I could click bidirectional and it would just act like it has a public IP assigned to it. So when it sends traffic out to the internet, it automatically gets translated to a public IP. When it comes back in, it goes from that public IP back to a private one. All ports pass through, everything else, I don't have to set up port forwarding or anything goofy. I just allow it to go through. And that kind of comes back again to the security policy that would go with that. I would have to specifically allow certain applications or services, or if I set any, it's blowing everything into the server, right? Now it's up to your server to do some filtering on that side. I don't recommend doing that. I recommend letting the firewall handle that kind of stuff. That's its purpose. That's it. So short topic, very confusing topic. All right. And I know that. So does anybody have any questions over NAT? How many of you guys have had to deal with NAT in the past?
Oh,
Maybe
yeah.
you guys, yeah, I figured you do. And I know RJ has some experience with it.
Yeah, I've got a ticket dealing with it right now.
Yeah. Has anybody set up just a web server or something at their home and they had to do port forwarding to get it out to the real world? Nothing like that. So that is like the most basic form of it, where you're doing a NAT translation in that case, but then you're also port forwarding something out. So we're going to open up the firewall where it's available on port whatever, 8443. You're going to translate that back to an IP address on your local network. My 192.168.1.2, that's where I host a web server, and it's actually listening on port 80, but according to the internet, they have to specifically go to 8443 in order to hit it from my public IP. All right. Very basic side, that is going to be the source NAT. The most equivalent to that is your source NAT. And in this case, it would be the dynamic IP import, this one here, and that allows you to translate it out. If you specifically wanted to map it to ports, then you would do dynamic IP, and then you could do the port number that you would do would be in your security firewall in that case. Right. If you're just having internet for users to gain out to the internet and you're not hosting any services, you will probably never have a destination NAT at that point. You would just have source NAT that would allow all your computers on your network, whatever else, to translate to one public IP so they have outbound internet. That's it. But remember, if you do a NAT and you can't get internet traffic out, you more than likely forgot the security policy of it. They go hand in hand. You have to have the NAT policy stood up, and you have to have a security policy that matches that. Last week, we set up this part, but remember, we couldn't get access to the internet. It's because we were missing the NAT translation part. So after Thursday, which, by the way, we won't have a lab day on Thursday because we have some other stuff going on campus, prepping for Friday, which again, Friday we have CyberCon, which is the cybersecurity conference. So if you haven't registered and would like to go, please go out to the website, register. That helps us with head count for lunch and things like that. It's free for you guys. Come visit lunch, come look at the workshops, that kind of stuff. But we won't have class on Thursday to go through the lab. Go through the lab. By the time you're done, you should have internet access at this point. And I've tested that with a later model and it's working just fine. So obviously, depending on how you set up this policy as to what services will work, right? So if you guys say any address, any application, and any service, you should be able to blast and get to anything out on the public internet at that point. Anybody else have any questions?
I had a question, but it was related to last week with the security policies.
Okay, let me have Stevens here, and then I'll catch up with you there, RJ. What you got?
I just wanted some clarification on like the internet to internet, I guess as like
Uh-huh.
source from internet to destination internet. That's like outside facing internet coming to inside facing internet.
Yes. So the idea here on this one is you are trying to get translated from whatever public IP is. Oh, it's still going to be pre-NAT. The key there is this being set up as pre-NAT zone. So you're coming in on the internet, you're wanting to translate that to an internet IP address on the inside, then you're going to go across. Your security is just saying go from internet to my extranet. But it's just on this NAT policy is when it's pre-NAT, and then post-NAT is on the destination where you're translating that on the inside. Clear over here, translated to this side here. In other words, I take traffic in, I am destined for this public IP address, so that's still in this internet zone. And then when it gets translated, it goes over to this IP. Now, once it gets to this IP, the policy kicks in and says, okay, now I'm going from internet to an extranet. You just have to think back in the flow chart. That one. There. I'm taking this source stuff till I get to this destination side of it. And at that point, do I have DNAT set up for going somewhere else? Then I need to make sure I'm translating to the right IP. And then we'll hit the security policies. So NAT gets checked first, which means I'm taking your IP address, I'm translating it from public to private. Once that's translated, now does it match a specific security policy? That's why it's internet to internet at that point. Make sense?
Yeah.
Okay. RJ, what did you have, bud?
So, on the quiz for the material from last week, there was a question, a true or false question about security policies, and the questions had stated that the security policies would be set on the interface. And I thought it was false because I thought that you would set it on zones because the interfaces could be remapped. So your policies would all be set to zones instead of directly to interfaces. Is that, am I off base on thinking that way?
I honestly would almost agree with you. In other words, a policy always has to have some zone set. It does not always have to have some interface set. Does that make sense?
Mm-hmm.
But every interface has to be assigned to a zone. So it depends on where it was asking that question. In other words, when you have a zone, it has to be assigned to a specific interface. And an interface can only be in one zone.
Mm-hmm.
So in other words, I would have to see what your question was and where you were at in there.
Yeah, the true and false stuff is sometimes kind of tricky as to what they are looking for.
I remember that question also.
Okay.
I thought the same thing.
Yeah, it depends on how it's worded and where it's coming in, but it was probably trying to do a true false of an interface has to be a part of a zone or something to that effect. I can go look up that question next time and I'll pull it up and see what you guys did. There are some questions that may be goofy or backwards, so if that's one of them, I just need to report it.
The other one was in our PowerPoint. Which type of security policy rule is the default rule type?
Yes.
And On the Palo Alto quiz, it said that the universal, which was what we had in the PowerPoint, wasn't correct.
What did it say was correct?
It was interzone, I believe.
It wasn't universal, but I thought it was universal. It said that was wrong. I remember that.
So it would be the universal type. And it's saying it was interzone or intrazone.
Yeah, I forget which one off the top of my
Okay.
head right now, but yeah.
I
Yeah,
will go
noticed
look that
too.
up because that one's wrong. It's definitely universal. Okay, I will go look those up and report them. And I'll give you guys back points too on that one. As a matter of fact, you guys you'll have midterm grades, I think by Monday is when they're due. So I'll go back and look at that. That was last week's quiz.
Yeah.
Okay. I'll go back and do an override on that one for those.
Policy rule is the default rule type. Intrazone, default, universal, or interzone is what that question was.
Yeah. The fact it says default rule type tells me it should have been universal.
That was more correct, but it said, oh, I know it says interzone.
It says interzone.
Okay. Yeah, that's not right. The only thing I can think of is if they're saying the default rules, not, you know what I mean? Like if you fire up the firewall, the first default rule it's going to hit is interzone, not intrazone. But that isn't a type. Does that make sense?
Yeah.
So unless they're trying to do some tricky question in there, that's the only way I could see where they would get to interzone. A better worded question would be, when creating a new security policy, what is the default rule type? And that should be universal. Okay, I will look into that one. Don't be afraid to bring those up, though. Like I said, they don't always get those correct when they go through. I did forget the questions here, so let's pop into this week's questions. Did I go the wrong way? Went too far?
One page too far. Back one.
It zoomed when there we go. All right, so on NAT oversubscription is used in conjunction with which NAT translation type?
I think it's one of the dynamic ones.
Remember, NAT oversubscription allows you to do what? Yes. Yep, but it has a very specific type it can be accessible to. Don't second guess yourself. It is static. Yep. Yeah, it only works with static IPs. Which source NAT type changes the course IP address? Course IP address?
Supposed to be source, I guess.
Yeah. I was going to say that. Okay. Which source NAT type changes the source IP address while leaving the source port unchanged?
Dynamic IP.
Yep. Dynamic IP, B. Yep. Is that what you said earlier? Yeah. Yep. The slide specifically said leave source port unchanged. So if you go back and look at that slide, you'll find it. When configuring a destination NAT security policy, what destination address would you use?
A.
It's a good question. So the question, somebody said A, and A is the correct answer. However, your question about what's the difference between egress and ingress is a good question. Ingress is anything coming into the firewall. Egress is anything going out from the firewall. So that actually could be two different interfaces in some cases, right? Which means it could be two different IP addresses in some cases. This is where a lot of people get confused, is this egress and ingress, because it could be egress of the firewall, but it's ingress to the port, right? So it's going out of the firewall, but coming into the port. Always think of the port and where the traffic is either coming in or going out of it. All right, true or false, SourceNet is commonly used for private users to access the public internet.
True.
Yep, true. This is what you guys are all doing on your home routers at home, right? You're using SourceNet to take your private users, aka your 192.168.1.0 network, and making it to where they can access the internet. All right, let's double check and make sure I didn't just blow up answers, but I've been known to get one wrong or two. So the first one was C. Okay. Now we're going back because I said it was static, and I don't believe that was static. I could have swore. Yep, go into the slides.
Hey, ready हो जाओ.
Dip NAT over script. Yes, that is correct. Okay. This was the one I had in my head and told you wrong. I was thinking of bidirectional. Bidirectional only works on static IPs. Dip is which, did that actually match C though? Yeah, dynamic IP import. Okay, yep. C. Yep, C is correct. D is not a thing. So my apologies for that. It is C. Bidirectional support is only done on statics. Okay, so there's C. That's why I got to go look. I'm not going to pretend like I know every answer here. ACA. A is your static that you were mentioning there. Address of the ingress firewall port. Aha. Yes. Okay. Destination address on destination NAT. So you were asking what's ingress, egress, right? They're saying it should be C, which is the ingress of the firewall. It's what's coming into the firewall. And therefore, when you do a translation, remember that is the IP address of the firewall as traffic comes in. It's the destination translation that is the web address. Does everybody see the difference there? So your destination address coming into the firewall, yes, you do want that to be the ingress IP address of the firewall. It's after it's translated, that is where you're looking to use your web server.
Yeah, web server was kind of a weird answer because it could be any kind of server.
Yep. This is why I check again.
That
Okay.
one was tricky.
It is tricky. That's why I said it. When it gets to destination NAT, things get really complicated really fast. And trust me, I put private IPs here trying to figure out why it does not work. And then I bang my head on it, and then I have to go to an old config, copy and paste it in, and figure out what I was doing wrong. Oh yeah, this. All right.
I was testing for your web server, but I just dropped it.
Yeah, because it wouldn't know how to do a private IP on the destination interface. The key helper here is destination zone, right? If it was my web server, it would not have this public IP here. It'd be a private IP. Therefore, this would not work. But because I have the public IP of my firewall, which is this here, that is what should be here as the destination address. Which makes sense, right? When we are advertising this service out to the internet, this is where they're going. If they go to fhsu.edu, it would translate to this public address, which would then get translated on the inside to this IP address.
I have a question on this example. The source zone and the destination zone are both internet, but wouldn't the translated address wouldn't be in the internet zone? So why is the destination zone the same as the source zone?
Because of the key here is this is pre-NAT, right? In other words, when this packet comes into the firewall, it's before NAT ever happens. So we are coming from some internet side to our internet IP address here. In other words, there again, this address that we're translating is in the internet zone for us.
Oh yeah, because it's in the security policy rather than in the NAT policy.
You got it. You got it. This is there again, that's where this gets tricky, is you're coming from anywhere on the internet to our interface here, which is in the internet zone. So it's internet to internet for us.
Like outside internet to inside internet.
Essentially, yeah. Yep. Yep. You have to think in terms of how your zones are set up. And in this case, everything out here, whether it's our interface or the other billions, addresses out here on the internet, they're all in our internet zone. Now, once it gets translated, now you have a security policy that you put in place for the translation thing. So you'll notice if its source is anything from the internet, it's destined for the address here. This is our pre-NAT address that you set up in the policy, not the private address on the inside. This will make sure that traffic gets directed to that private. This is going to make sure that it matches this policy coming in here. Destination NAT is extremely tricky.
Yeah, I had that ticket come in today to create a port forward or NAT policy, but I went back to him and said, hey, I don't want to just do this with a security policy to just open these ports up to the internet. I'm like, this is a phone server. It's going to be coming from a specific range. What range is it coming from? So I can whittle that down so that the whole internet doesn't have access to your phones.
You got it. Yep. The tighter you can make those security policies, the better. So a good example of that is Sunday. I came in here to go get some work done. That did not happen. I got a phone call that nobody could connect to the global VPN, Global Protect, right? Which is in the Palo, and we're going to cover that in coming weeks. We have always been constantly inundated with attacks on the global VPN because we have a login page. So you go to our VPN website, so to speak, which is the Palo Alto. That is where you can download the VPN client. And then once you get the client, then you can go ahead and use the client to log in, right? That little login page just sits there and gets hammered from everywhere in the world. Doesn't matter. It comes from everywhere. I have to go into my Global Protect logs, and all I see is a series of failures. And in our case, that actually authenticates against a SAML connection back to Google so that we can use our Google addresses in order to do that. So my email address at blah, blah, blah that uses Google Workspace, we're using that for authentication versus the local AD. We have local AD as a backup, and then you have what as your number one failback on a firewall? You guys remember that from the users? Local. Yep. So you have the local database on the firewall. So it goes from our SAML. If SAML doesn't authenticate us, then we'll go to our Active Directory. If Active Directory doesn't work local, it'll kick us to the local on the firewall, which means you probably only have 2 usernames on the firewall, your administrator and maybe a different administrator account kind of thing. Anyway, they were attacking so much that it essentially caused a denial of service, and the Global Protect service locked up. I had to end up rebooting the firewall to fix it. But by going back and cleaning up, making sure that We don't have the login pages exposed. And then we initiated a blacklist. And Palo Alto has blacklist or IP address ranges that are known to be bad. And so I put two policies in there, one for anything coming from those addresses to our system, drop the traffic, right? Not deny, but drop. The old administrator had it set as deny, and it was just causing the management CPU to start climbing, right? Because we had to send response packets to everything. So I set it to drop, so we just drop the packet. Then we have another policy that says anything from inside our network going to those IP addresses. Well, obviously that's bad. That means something on our network's compromised and sending back to known bad IPs. We're going to block that traffic as well in the case of a deny. Then I took all those authentication IPs that were sitting there just banging our system left and right, dropped them into a blacklist, and then fed that into two rules that said block anything destined for those, block anything incoming from those. By Sunday at 5 till this morning, we had over 500,000 hits on just that blacklist. That's how constant you're going to get hit with this stuff. So stuff like RJ said is, well, can we limit that down a little bit? That's a really good idea, because if you leave it open, you're going to get attacked nonstop from everywhere. In this case, they are on a education system, much like Fort Hayes. And so a good example of this, just a couple weeks ago, like 2 weeks ago, I was testing a firewall here in my office. I plugged in an Ubuntu client machine to the internet. I had the password set as password, right? Because it was just going to be a very quick, dirty way of testing a firewall. It was going to have a private IP address, had no access out to the internet whatsoever. I temporarily put it on the internet just to download the packages and the updates I needed, then swung it off. In the 15 minutes it took me to download those packages, that system not only got compromised, but was being a bot and being used to attack somebody over in Russia, I think. And so we got a cease and desist letter over the weekend when I had been doing that. 15 minutes is all it took on our public network here to get it compromised and being turned into a bot and start sending out traffic. Now, do you think a human was doing that? Absolutely not, right? Because today we've got AI and a bunch of other stuff out there that allows us to constantly send this stuff out. And once you get in, set up a backdoor, set up a bot, now it's accessible from anywhere. And it becomes part of the next botnet that's out there, which there has been some massive ones that have come out here lately. Just all of a sudden popped up out of nowhere. So as firewall administrators, this is stuff you have to go back through. So now I go through. My Global Protect's now cleaned up. I no longer get access failures because I basically killed those login pages. If somebody needs to download our client, there's 10 people in the company. Just ask a person for the file. You know what I mean? I don't need to have it launched as if I have 20,000 users for our VPN. Let's just share the file internally as needed. Then I went back through our threat logs and I started pulling all of those IPs. And if anybody was really hammering all of our systems, they got added to the blacklist. And so you guys can do that manually like that, or you can start building in where you're scrubbing those logs, sending those over to a SIEM like we talked about in cyber operations. And then once you get a known list of them, you can use the XML API or the REST API in the Palo to start injecting those IPs in there. So, and we'll talk a little bit about that later in the semester. We'll talk about external dynamic lists where you have a text file on a FTP server locally. As long as you update that text file, it will dynamically inject those IPs into the firewall and block any of those IPs or web URLs or whatever else you want it to do, depending on how you set it up. In this case, we were using their dynamic address groups. And the reason for that is you can only limit 50,000 IP addresses from an external dynamic list on the particular model of firewall I'm using. I can block 87,000 IP addresses if I do it via the API. So learning the API, which is back to your Python skills, everybody that's in cyber had to take Python 1 and 601, hopefully. You will be able to use those skills in order to interact with this firewall system. That's the reason I have the cybersecurity stuff set up that way, is you will be using those to manage firewalls at some point. If you can do it all by hand, great. If you get paid by the hour, I encourage you. But if you're a salary employee and going to need to move on to other stuff, start learning how to use the APIs. All right, that's all I got. I'll shut her down.